Welcome to Fact Axis, where today, we're going to be going over the top 10 amazing facts about dark matter. Make sure to stick around for our number one fact, because it will certainly bend your mind. Number 10. We can't see it. The problem with dark matter, that unlike much of the other matter out there, it doesn't emit anything that we can accurately measure. Dark matter, for instance, does not emit any electromagnetic radiation at all, based on our observation. Astronomers cannot have been able to see any light, nor radiation being emitted from dark matter. This includes X-rays and radio waves. When tested at higher energies, the results are the same. This is partially what makes dark matter such a new and elusive concept, is that we know it's there, but proving it is a whole other task within itself. This is why the coming future, there's going to be a lot of time and resources spent to looking into more things dark matter and dark energy related. Number 9. Matter is broad. Physicists judge everything that is matter, but what and how it behaves in our current time and space. So, if dark matter doesn't exactly fit that criteria, then how does it constitute as matter in the first place? Well, this simply just means that dark matter dilutes as it spreads larger and larger in volume, while having the same gravitational qualities as other matter does. Dark energy, however, does not have these same qualities. Dark energy and dark matter are not the same thing. Far from it, actually. Number 8. Eternal existence. Something has got to be holding the very fabric of our space and time together. And you guessed it, that would be dark matter. It's this reason alone that dark matter will always exist, and continue to exist, and always has existed. This is due to one large and obvious observation. Galaxies have far more larger gravitational pull than any visible matter can possibly have. Then, you have other galactic oddities going on, like temperature fluctuations, and the general structure of galaxies with dark matter working behind the scenes. See, dark matter is kind of like an engine of a car. You know the car is on, you can see the car moving, but the force at work is the actual engine driving the vehicle, other than just the car physically moving. The point being is there is more at work than what can be physically observed. This makes dark matter all that more interesting for scientists and astronomers alike. Dark matter seems to be a very important and unseen piece of architecture to the entire structure of our galactic makeup. Number 7. First glance. Vera Rubin has given a lot of attention to the matter that is the dark in the universe, and she is considered to be one of the most prominent scientists in the field of astronomy. In fact, one of her most important contributions to astronomy is the compilation of conclusive evidence pointing to the existence of dark matter. These can be explained, but if more matter is also present, it would prove to be a high problem for the model of how the universe works. When it comes to explaining what dark matter is, no real general theory can ever be complete without including this mysterious substance. She has even been called a pioneer in the field of science, and she deserves that title. While she didn't exactly discover dark matter, she was the one responsible for bringing it to light. Number 6. Introvert. Dark matter doesn't really interact with any other forms of matter. A perfect example of this is the bullet cluster, which is actually two clusters of galaxies that have at one time or another passed through the other. Using emissions of X-rays, one can fully detect the distribution of both dark matter and regular matter that we're all familiar with. This is done by a process called gravitational lensing. Judging from the data, it appears that when regular matter passes through each other, it will distort and slow down. However, when dark matter passes through each other, it remains completely undisturbed. showing no signs of contortion in any way. If you enjoy these videos, make sure to subscribe and turn on notifications so you don't miss more amazing top list videos. Number 5. The original architecture. Dark matter is incredibly unique. I mean, it's virtually responsible for all structures in the universe. Since dark matter does not interact with really any other forms of matter, it's actually able to form structures under its own gravity. Dark matter is kind of like the blueprint, where visible matter takes form and shape. One of the biggest mysteries in astronomy is what the origin of dark matter is. Astronomers believe that it makes up most, if not all, of our universe. All the matter that exists in the cosmos has a definite amount of electromagnetic radiation emitted by it. Some types of this electromagnetic radiation are known as cosmic rays, while others are called radio waves. The latter type of radiation is called cosmic microwave radiation. We know that the radiant energy produced by the atoms is due to the interaction between photons and electrons, but we do not know the properties of this cosmic radiation. So, astronomers have inferred the existence of dark matter indirectly by the fact that cosmic radiation emitted by some moving particles tends to have a very different energy spectrum than that emitted by other moving particles. According to these calculations, the dark matter should possess a baryon or anti-baryon spectrum. Baryons consist of both a neutral and an ion. Ionized molecules are made of ions which have negative electric charges, and neutral molecules are composed of neutral protons, neutrons, and electrons. According to the calculations, dark matter should be made up of a combination of ionized molecules and neutral protons and neutrons. If you calculate the average kinetic energy of ionized molecules, using the results should match the results given by the calculations made for neutral molecules. Number 4. Unbalanced distribution. Dark matter does not engage and interact enough to form objects as dense as large celestial bodies called planets. However, it does have halos of varying density that move around in galaxies. Since dark matter does not turn with the disk of stars that we observe, solar systems like our own continuously move into a wind of dark matter particles. Dark matter's density is generally larger towards the center point of galaxies. It is also not entirely smoothly distributed within galaxies. At least that's what the best understood models will tell us. Number 3. Ideas and speculation. Currently, the most popular explanation for the confusing observations is some type of weakly engaging particle that does not engage with light. These particles need to be quite massive to form the observed structures, about as heavy as the heaviest particles that we can understand. If it was so that dark matter particles weren't heavy enough, they would not clump together adequately. This is why they are known as WIMPs, weakly interactive massive particles. There are other kinds of prospect particles that have more complex interactions or are much heavier, such as WIMPzillas and other exotic things. Macro dark matter is a kind of dark matter that could be accommodated in the standard model. It includes macroscopical heavy chunks of unidentified types of nuclear matter. Then, there are a number of other propositions for how to modify gravity to accommodate the observations at hand, like MOG, entropic gravity, or bimetric theories. Extremely different by inspiration. The more observations need to be discussed, the more similar the explanations through additional particles have actually ended up being to the descriptions through modifying gravity. Number 2. Black holes and dwarf stars. We understand that dark matter can't be made up by dwarf stars or even black holes. The main reason this does not work is that we understand the overall mass dark matter brings into our galaxy, and it's a lot. about 10 times as much as the noticeable matter we can see. We also know that this isn't the result of black holes because, well, we would see a tremendous amount of gravitational lensing. Plus, dark matter clumps together in a very specific way to seed galaxy filaments. Number 1. No actual evidence. Despite decades of research, no one has ever straight identified a dark matter particle, and the only proof we have is still indirectly inferred from gravitational pull. Physicists have actually been searching for the unusual interactions of proposed dark matter prospects in numerous Earth-based experiments, dating all the way back in the 1980s. After whatever the universe has informed us about itself, we're convinced that some type of dark matter must exist. Matter that's various from any of the known particles in the standard design. This dark matter outmasses all other particles and radiation in the universe by an element of 5 or so, but has yet to be directly identified. That wraps up today's video on the top 10 facts about dark matter. Let us know in the comments below what your favorite fact was. And be sure to leave a like and subscribe for more great list videos, only from Fact Axis.